In the previous lecture, we have seen how pass1 is working. So this pass1 is working depending on the algorithm. So we must know what is this algorithm, because this question will be asked for around 7 marks in the university papers. So let us understand what is how this algorithm is working. So just to revise the concept of previous lecture. So let us start with this lecture. So this is the algorithm. So you can see algorithm of first pass, that is algorithm of pass one. So as we know, location counter is first of all by default has to be 0, which will be later initialized with some value which is given by the start or origin. Pull tab pointer, obviously at the start it is initialized with 1. Pull tab array into bracket 1 is initialized with 1. Literal table pointer initialized with 1. So by default entry of literal table is 1. Then pull table pointer is at start initialized with 1. So that is again incremented later on. So let us go to the next step. While next statement is not an end statement. So whatever is given here, A, B, C, D, E, F. So these steps A, B, C, D, E, F must be repeated till we encounter with end statement. So this is a repeated process. Now we'll see what to be done before end statement. So these are some possibilities. A, B, C, D, E, F. These are the possibilities of different statements that we encounter and uh, how the program should work, that we need to see. So let us start with 2.A. So if label is present, here you can see, just if label is present, label means we have seen that loop was the label in our program. Again, uh, I appeal you to open the program so that whatever I am telling you, you can understand. So in the program, you can see loop was there, which was uh, representing label. So this label is nothing but symbol. So this label is equal to symbol in label field. Enter this label, that means loop, and location counter in the symbol table. Now you can see the program. Start was initialized with 200. Then the next instruction move r a raised to comma 5 was at 200. Move m a raised to comma a was at 201, and loop was at 202. So loop was entered into the symbol table with address as 200. Sorry, 202, and its length as 1. So these are the three entries: loop, 202, and 1 into the symbol table. Because this enter method will put the details into the symbol table. Next is if an LTOR statement. So we have seen that after encountering LTOR statement, whatever the literals are there, which are there in the literal table, will get allocated with some memory. So in the program, you can see equal to 5 is allocated with 211 and equal to 1 is allocated with 212. So how that is processed, let us see. First of all, after encountering LTORG, process literals means what? Process literals literal tab into bracket pull tab into bracket pull tab underscore pointer. So what is this? This is literal table and this is pull table. Pull tab underscore pointer is initialized with 1, and uh, pull tab into bracket pull tab underscore pointer initialized with 1. So this entry will be 1. So first literal will be taken to allocate memory and put the address in the address field and update location counter accordingly. How to update the location counter? So pull tab is incremented by 1 because next pull will come into picture. The entry of pull table, how? Pull tab into bracket pull tab underscore pointer is equal to literal tab pointer. So whatever literal tab pointer is there, that will be incremented and will be added here. So in this way, equal to 5 will get address allocated, equal to 1 will get address allocated. Next is if start or origin statement, then start and origin are the two statements which will give new value to the location counter LC. So LC is initialized with the value given by the start or origin. What to do if EQ statement is encountered? EQ, you know, it is advanced assignment directive. Just what is that address? This and at the current address is nothing but value of the address specification. So this value is assigned. So correct the symbol table entry for this label, comma, this address. Means current label and current address is to be added whenever EQU comes into picture. So to understand this, in our program, we have EQU at instruction number, I think, 22. So at 22, you can see back EQU loop. So this address of loop is assigned to the back. That is how EQ statement works. So these are A, B, C, D, 4 steps of point 2, which is repeated until we encounter end statement. So let us go to the next. E. If declaration statement, then what is to be done? So code of the declaration statement, obviously that will come. Size of the memory area required by DC or DS. So now keep in mind, DC, declare constant, always needs size as 1, and DS needs the size whatever the storage capacity is given. So location counter is equal to location counter plus size. So already I told you LC will be incremented if DC is there, and LC will be added with some value depending on the storage size. So now generate intermediate code, DL and code. So this code is generated intermediate code using generate method, generate IC, DL, code. Then next is if an imperative statement. What to do if the imperative statement is present? Now code is machine of code from the OP tab. Whatever machine of code is there, that code will be taken. Then location counter is equal to location counter plus instruction length of the from the OP tab. So we have taken length of mover as 1 from the OP tab. Next, if operand is literal, then put that operand into the literal table by without giving any address to it. And if operand is there, then put the entry into the symbol table with its code and s dot entry. Generate intermediate code with is comma code into bracket s comma this entry. So whatever is there, whatever is given here, generate IC and generate IC. This intermediate code, yeah, I have not taught you intermediate code yet. The next point is of intermediate code. So we are going to see how the intermediate code is generated. So don't worry about these 2 points for right now. E and F. We are going to see how to generate intermediate code, and in that you will learn all these points. Last step is after what to do if we encounter with end statement. So processing of end statement. Perform step 2B. Then generate IC AD,02 because AD,02 assembly directive is nothing but end. So generate IC AD,02 and then go to pass to. So this is to be done after encountering end statement. So what is this? Perform step 2B. So step 2B is here. If an LTORG statement. So already we know LTORG, if an LTORG encounter, then allocate memory for literals. And at the end, if an end statement is encountered, then also allocate the memory to all the literals. So if LTORG is not there, end statement will do the work of LTORG. If exclusively LTORG statement is given, then LTORG statement will do its task at that point, generating new pool, and end statement will again allocate memory to all the literals, generating second pool. So this is how this algorithm is working. Concluding remark, thus we have seen algorithm of pass one of the assembler. Slide credit goes to Professor D. M. Damdare. Happy learning. Do subscribe the channel to get the notifications of new videos. Thank you.